between the University of Toledo, Boston University, WestEd, and the University of Berkeley, Tennessee State, and NASA. The NASA entity is specifically NASA Langley. What we're doing is bringing together GLOBE with NASA assets, and then getting students and teachers to do projects. So I was telling Joe, or teasing him about not having a picture, so I put his school picture here. He's going to be talking today as our teacher feature from Clay High School. And then Sarah McCrea is going to, from NASA Langley, is going to talk about the revised GLOBE Cloud app. Before we get into some of that, I do want to remind everybody we have the virtual science fair. Projects are due April 3rd. The students would submit those on the GLOBE website. US, we have the regional science fairs. Oh, I still haven't changed the name. Symposia or symposium. I have to change the name. One of these days I'll get it. And these are the dates for the different regions. The Midwest is going to be at Purdue University on May 19th and 20th. We have a number of them on that weekend. The Southeast is before that, and the Pacific is after that. And also great opportunities to take your students to the annual meeting for GLOBE. And this year it's in New Haven, Connecticut. I think it's the University of Southern Connecticut. And at the end of July, beginning of August, it's a great time for kids to meet students that have similar ideas from other countries, as well as scientists and educators from around the world. Now, I was going to give an update on the Urban Heat Island Surface Temperature Field Campaign that happened in December. I was going to do that last webinar, and I forgot. So I'll just do a quick update. We had 59 schools participate from around the world, over 1,300 observations, a lot in Ohio and Michigan, Eastern United States, Croatia, let's see, Saudi Arabia, Taiwan participated. But for the first time, we had a school from Colombia that was new, and also Kenya. And just going back to a flight, so NASA is flying a thermal sensor over Toledo and then Lake Erie. So if you're in this region, I'd encourage you to have your students take surface temperature observations for GLOBE and enter them on the website the week of February 20th. And the plane will go over probably sometime around 3 o'clock. So it's later in the day. So maybe kids would have to stay after school to do it. But we are having a webinar on Tuesday, the 14th, for students from 10 to 11 a.m. Of course, if your students, you don't have a class or, the schedule, you can have them call in at any time. And Dorothy Haw, who's a NASA ice and snow scientist, will be our speaker. And then I'll do some things with Urban Heat Island Effect and talk about it. The flight is actually to do snow and ice cover, but they can look at Urban Heat Island Effect with the same sensor. All right. So what I'm going to do is turn control over to Joe, and Joe will be our first speaker and talking about how he's doing GLOBE in his classroom.
Okay. Can everybody see the PowerPoint?
No, not yet.
Not yet? Okay, sorry.
Can you share screen? Then you have to double click on the window. There you go.
Okay.
Good. Okay, great.
So let's talk a little bit about clouds at Clay High School. We are actually located a little bit east of Toledo. Here on the map, it's that wonderful yellow pin. We're only a couple miles south of the lake. Cloud observation takes place at that nice little short red line. It's right by our wetland site. I'm one of two teachers out there that is actually participating in Globe Data. The other is our ag science teacher. Hers takes place just south of that big arrow. I'll have a better picture of that here in a second. The site itself is that lovely yellow line, but we observed the cloud data just a little bit south of it, mainly because it's really cold and there's a lot of trees around the pond. We walk about half a mile to get to our site. We have our wonderful windmill out there. Should have been a blue arrow, but oh well. Our site itself, looking close up, we have a relatively short pond. It's about, oh, I don't know, just around 6 feet deep in the center. Again, trees surround it, and at the hill right there at the bottom with that one single lone tree is where we take most of our cloud data. And over there on the picture, you can see the wonderful image of what my students have to deal with to get their hydrology data aside from the clouds. What we use, eyes. Normally, I wish the kids had two, but one will do fine. Technologically enhanced are also acceptable. We use a cloud chart and a clipboard, and I have the kids write down paper or on paper when they go out there, because it's about a half a kilometer away from our classroom, so we don't have Wi-Fi for the students' computers, which makes entering data online a little bit hard, and a lot of my students are worried about data rates. They still play Pokemon Go pretty heavily, so it's a little detrimental. We also take an infrared thermometer with us, so we can get the surface temperature when we take data for the cloud. Recently, when it's been cold, my students have been complaining.
Please mute your line if you have a computer. You can hear Joe. We're getting a lot of feedback from someone's computer or their line.
Okay, I'm gonna go ahead and continue then. My kids are complaining a lot, but I keep kicking them outside anyways recently in this wonderful cold weather that we've been having. We go outside, we tend to walk about the half a kilometer back. They form a square with the kids each looking off in one direction. And then we use, or they use their hands to help determine the size and height of the clouds. And I have a couple pictures for that. So here we're looking at some of the good and bad habits. I have the kids facing in the four directions, though I will admit that this photo is a little bit staged for this presentation. And then we can kind of see another good habit where the students are actually writing down the information before they run back inside. Bad habits with regards to this, you kind of have to dress for the weather, and the kids aren't particularly inclined to do so. They always say that they forgot. So I have a couple extra jackets that I send them out in when they need them. For surface temperature data, good and bad habits, I had some of the students who take my hydrology data try and take the surface temperature to kind of illustrate. And what they were doing is they were not pointing directly down. Instead, they were kind of pointing off at an angle. Whereas the student who normally takes the surface temperature data for me is illustrating it more correctly, where he's actually angled it down and is about a meter above the ground, so it gets a more accurate read. For reporting the data afterwards, you log into globe.gov. They enter the data and they choose the site. We have, I think, about 8 different sites that are potentially used for globe data at Clay High School. However, my class has mainly been focusing on the wetlands this year. They enter the date and time, and it's preferable to use the solar noon. However, my classes are at the beginning of the day and at the end of the day, so I fall into the good enough category of at least they're taking the data. We also enter the surface temperature, and then we enter the cloud data. Some motivation tips. I let my students pick what they wanted to observe from the globe menu. So I had some kids who picked clouds, and I had some kids that picked nitrates, others who picked dissolvable oxygen, and then I had some kids who are interested in green up and green down. So we've taken the green down data, but we have not taken any green up data yet. I tried to make these goals relatively clear at the beginning of the year, saying that we were collecting this data to help NASA and scientists worldwide, and we wanted to make it accurate and achievable. That led to setting manageable short-term goals with the goal of trying to really get out there once a week and actually take the data correctly. And then I've let them practice a lot of techniques before they had to do their projects, because part of my class requirement this year was to do a science fair based off the globe data. I had a bunch of groups that actually participated with the cloud data and did a relatively good job. And then I have had some opportunities for the kids to change. And then for my last slide here, there's a popular YouTube host who actually shared some helpful tips about science fairs. And he's given about 10 ideas on projects, none of which relate to globe. However, the hints that he provides there are pretty applicable. And he has a couple good quotes in there that you guys might use to help motivate your kids as well. I know that was really fast. Any questions?
Thanks, Joe. We'll wait just a second for questions here in the chat box. So good job, Joe. There you go. One thing I was wondering about, Clay High School has pretty much a full-size wind turbine. Do you do any projects with the wind turbine?
Last year we did a dead bird study, and it was supposed to go out to Camp Perry, but we were butting heads with the conservation group, or the Black Swamp Observatory out at Ottawa Hills, or not Ottawa Hills, the Ottawa Wildlife Reserve. And so the data was determined to be infallible, or not correct.
Right.
Invalid, yes. And we had basically 30 days worth of data, and we didn't find any dead birds, but we did find one dead bat. Mm-hmm. We also collect the data for the school, and our windmill powers about 90% of what the school needs.
That's great. So why was the data invalid?
They said that my student search techniques were not frequent enough, even though we had 30 days where we had about 3 days a week of going out and looking at data. Okay.
Elizabeth asks, what are some of the science questions that the students are researching?
I have some really basic ones. Mm-hmm. I have a kid that did the daytime versus the number of clouds. And then I have, like, on the other side of the scale, I have a student looking at nitrate levels before and after a farm to see if she can determine if a farm is a point place pollution for nitrates rather than a non-point point pollution. Sorry.
Right.
For nitrates.
Just trying to see what's coming off the farm field as far as nitrates is going.
Correct.
Yeah.
And she got really good data in the fall, not a lot of good data in the winter, which kind of makes sense because nothing's really going on the farm on the winter. And then she's hoping to get some more before she submits in April.
Okay, great. So any other questions? I'm trying to do that dramatic pause, they're But you let your students think, because a lot of professors don't give their kids a chance to say anything, right? Ask if there's any questions, and they move on. Diana says that your windmill sounds awesome.
It's really fun. We also have 3 little ones that are associated with our 5th through 6th grade building.
Oh, wow.
So that powers their building by 100%, I believe.
Wow. Great. All right. Well, thanks, Joe. Thanks for sharing your experiences and what you do with your kids. So now we'll have Sarah McCrea. She's going to talk about the new or revised Globe Cloud Protocol. So Sarah?
Yes, hi. Thanks for having me. Can you hear me?
Yes.
Okay, great. I'm going to go to sharing my screen, so give me some thumbs up or down when you can see it.
Coming in. Now we can see it now.
Okay, and I think I'm going in. Can you see the full screen now?
Yes.
Great. Okay, well, Kevin did a great kind of introduction of how we play a role in Mission Earth, but I was going to kind of overview and showcase how a lot of these great NASA and Globe products fit right into your classroom, and Joe just did a great example of it. So my goal today, I see a question, which I don't have open, so I might ask Kevin, if you see a question come up, just let me know.
Yeah, I'll do that.
Okay, perfect. So I guess by show of waving or hands, or just a quick mic on and mic off, how many people are familiar with the Globe Cloud Protocol over their past experience of teaching? I see a few hands, great. So what we've done is NASA and the Globe program have collaborated over the past year, and I'll go into explaining it a little more with some of my slides, but we've worked together to bring a program that has been active out of NASA Langley, including satellite matching to ground observations, and pair that with kind of the robust science skill set that Globe protocols bring to the classroom. So to start that off, and I think I could go to my next slide. There we go. Globe itself, that many of you know, has kind of that vision of a worldwide community where it's bringing everyone together from teachers, students, trainers, connecting them to the scientists, and creating an understanding of more of our world around us locally, and then tying that to regional effects and global effects. And the whole opening of this presentation has done a great job of that, showing your local observation areas, expanding a little bit to what that means over the Toledo area, and then we'll go in and I have some examples kind of on a global scale. And our goal with this resource is to kind of promote you in the classroom to help the learning of science, enhance environmental literacy, and in my view too, really prepare you for the classroom. So protocol areas are, and most of you are familiar with this, the biosphere, atmosphere, hydrosphere, soil, and then larger Earth as a system. So Globe has all those different protocol areas, and then under each sphere, there are multiple protocols to break it down for you to help you with observations and data collection. So we're going to dive right into the cloud protocol. So I know most of you waved your hand and said you are fans of the current cloud protocol. But like I mentioned, what we've done with NASA Langley is we've brought the Student Cloud Observations Online program that has actually been kind of running parallel to the Globe program for the past 20 years, but just focused specifically on clouds and tying that to satellite matching. So what we're doing is enhancing that Globe protocol that existed with this process out of the NASA Langley program. So you enter the same ways, either as an educator. You could draw on the screen? Awesome. Okay. So you enter as an educator, and I also have informal up there because we have opportunities for those outside of the classroom, but also there's a new application that we're creating that I think might be helpful, and I made a note to mention it to come back around when we talk about if you have internet or not. So you can enter as an educator or as an informal person outside of the classroom. But then once you enter and start participating, the process is the same. You request satellite overpass times, which I'll have an example you can do through the website. So if you're familiar with the Globe website, we'll have a new Support NASA link on the Cloud Protocol page, and you'll be able to access your data, satellite overpass times, and what it does is it pops right up on the screen for you. It can pop up within the Citizen Science app, or it'll even email you if you're a Globe educator. Then what you would do is observe clouds and report clouds, which is walking through the same kind of customs that you're used to with the normal Globe protocol. We've just kind of enhanced it with a few extra parameter areas to observe. And then the new kind of value that we're bringing to the Cloud protocol is that once you submit your cloud data, what's going to happen is if you've observed during a satellite overpass, which means a satellite has flown over your area, or in the United States, basically hourly, you're scanned by a geostationary weather satellite. And what we're going to do is match your ground observation to that cloud data and send it right back to you in an email if you're a certified Globe educator, or you can access it on Data Viz, which I'll show some examples of later, but within the Globe website, there's data visualization, and you can click your observation on the screen, and it pops up your metadata, and there will be a link right there, a URL, that you can go to your match, which I'll show some examples of later. And then within the match, you can compare your observations to satellite data. You can be the scientist doing the interpretation, and you have room to comment and start a conversation with the science team on the NASA side. And then repeat, rinse and repeat as much as you would like. So the Cloud protocol itself, what it is the purpose to observe type, cover, and now opacity, which what I mean by that is the ability of clouds to let light through to the Earth's surface, including even contrails, and compare the view from the ground with that of space. So that's where this new satellite imagery comes in. So this includes, we've updated the cloud chart to hopefully be more simple and accessible to take outside with you in the field. We've updated the report form to hopefully make it more streamlined, and a few other kind of supplemental and complementary materials on the website. So our goal is to have the students learn how to make these estimates and observations, how to categorize and classify specific cloud properties, following these general instructions. And then the ideal goal is to kind of follow that path of what you heard from Joe. Have your students actually come up with that science question, have them participate in the Globe community through the virtual science fair and the annual meeting, and have them participate in the community. So what is new? For those of you who are familiar with the Cloud protocol, currently you observe cloud type as a whole, and you can observe other ground conditions like surface temperature, barometric pressure, relative humidity, and you tie that all into one observation. So what we're doing is tying onto the cloud observation, you'll also be asked to observe sky conditions. And what I mean by this is visibility. So across your horizon through the atmosphere, what's your visibility? And sky color. So you're looking at the bluest part of your sky, and compared to these 5 categories, how blue is your sky? So some tips and tricks when we're in the field around these areas. And I see some flashing.
Oh, did you want? I wasn't going to interrupt you right now with the questions, but
Go for it.
Good. And I think you're going to go over the satellite matching again.
Yes.
So that's one. But Travis asked, which satellites do you use? Will you go over that?
Perfect. I have a whole slide just dedicated to that.
Okay, great. We'll wait for it then.
So I'll touch on those, and if I don't get to them, remind me.
Okay.
Thanks. So to start out with, we have the total sky conditions. So I talked about kind of what they are, but the reason we have these added on is because if a student or a participant is looking up in the sky, right, we're telling the difference between two things, blue sky and a version of white clouds. So for example, on those days where you have a clear sky or no clouds, you still can learn something about the science in the atmosphere around you. And these sky conditions, visibility and color, tell you something about the aerosols in your sky. So for example, if you're looking at a really extremely hazy visibility and milky color day in your sky, you know that maybe you have a little more aerosol or larger aerosol content in your atmosphere. What we do is we usually have students take pictures of their sky on a clear day. And what I mean by that is after a front moves through or a storm a big thunderstorm has cleaned out your atmosphere, for your area, that's usually going to be the time when you see the most clearest conditions. Some tips and tricks on how to observe these. For visibility, you are looking across your horizon, so out across in front of you. And for sky conditions, you're trying to find the bluest part of your sky. And this usually happens about halfway up between 90 degrees and the horizon and with your back to the sun. So we added those observations in there. We also added the observation of visual opacity. Now, I know a lot of our discussions with educators has been the terminology here, but with school, we've really found success over the past 20 years with the way, the tips and tricks on how we observe this and how we explain it. So visibility, they learn shadows and they learn light. And we have some activities that actually go along with this parameter of, testing materials out in your classroom. What's transparent? What's translucent? What's opaque? How can we test that? So we have on each level observing the visual opacity of that cloud level, because that relates back to how much light gets through to our surface and is affecting surface temperature in those Earth systems. A tip and trick on how to observe visual opacity is looking at your shadow. So if you have a really crisp, clean shadow on the floor or on the ground in front of you, a lot of light is getting through that cloud above you. So you'd have a transparent observation. And all the way to the other side, where if you have a very fuzzy or little to no shadow, you're looking at an opaque shadow or an opaque cloud level. The new thing too is we're breaking out these observations into the different cloud levels, low, mid, and high. So on each level, you'll be observing type, cover, and visual opacity. And we do this because when we're comparing to that satellite imagery, we want to add a layer of understanding. So for example, some of the students might have heard of ground observations. We also at NASA fly, like Kevin was just going over, air missions or with planes. And we also have satellites from space. So each of these layers adds a bit of understanding and perspective. So a good example of why this is valuable is for if I'm looking up from ground level and my low level is overcast, I might have a hard time seeing mid or high level observations of clouds. But if I can add a satellite image to that or view, I can add some understanding of my mid and high level clouds above where I can't see. The same is true for satellites. So by splitting it into those different levels, we kind of gain a bigger, better picture of what's happening with clouds in the atmosphere above us. And the last thing we're adding is surface conditions. So those of you who are familiar with GLOBE, we do have land cover, but from school we brought over surface conditions. And what I mean by that is in the area around you where you're observing, or in your site, your defined site, for example, is there snow and ice on the ground? Standing water, is it muddy? And this really comes into play with this example here. So Kevin, you might have to help me with answers from the chat. But if you guys could guess, what is the percentage of cloud cover in these two pictures? So let's go ahead with left. Could you please enter a guess, just shout them out, of the cloud cover in the left picture here?
All right, you have 7 from Travis, 47 from Elizabeth, 76,
Good.
15 from Russell, 60 from Paige, 15 from Joe, 0 from Melody, interesting, 59 from Sonia, 25 from Richard.
Great.
Everybody's putting them in, so
Right, so
forward.
I see it, yeah. So we have a range, right? Okay, so now let's guess. So I'm going to call that, we have a little high ones, a little low ones. So let's call that around 50, 65 is the most I'm seeing right here. Okay, how about the right image there?
All right, right image.
And I pulled it up, so I figured out how to see the chat.
Okay, great.
So 45, 52, 35, 40, 55, 55, 50 to 60. Awesome. So keep throwing them in there. Now I'm going to start the conversation of, so we kind of have, some guesstimates are kind of close, right? Between the right and left picture. But if I go to the next slide, which I would do by clicking back on my slides, we'll see that the picture on the left is actually 25% cloud cover compared to the one on the right. The satellite image is 75% cloud cover. And you can go ahead and write in the chat, because I have it up now. What do you think the difference is between these two pictures? What might I be looking at in the left picture that's not in the right one? Perfect.
Mm-hmm.
Ice, snow, amount of snow. Exactly. So when we look up at the sky, we're telling the difference, like I mentioned earlier, kind of between the difference between a version of a blue sky and a version of a white cloud. When a satellite's looking down, that imagery is trying to tell the difference between a white cloud, white snow or ice, land cover, snow cover, water cover, forest, urban, rural. So by adding our perspective, we might be able to tell, for example, the left image, that snow and ice are covering the whole top of that picture in a mountain range, while the clouds only exist at the bottom, across the bottom of the left picture. And on the right, the clouds are all across the top and kind of speckled along the bottom, which we start to be able to tell by the textures and the shadows that we see. So not only initially by reporting are we adding a level of understanding, but also coming back around with interpretation, we get to help add that level of understanding. And actually, when we first started school, students were the ones helping us validate our algorithms, making sure our satellites were seeing what they were supposed to. So that all brings us, how did you calculate the percent? Is there an instrument to do that? So that's a good question. One, this brings up a really good teaching moment of satellites are, well, the ones that we use to match to clouds are kind of, we explain them as buses. And they carry a lot of different instruments that we explain like students. So different instruments are measuring different things. So one instrument could measure that percentage one way. Another way to calculate the percentage is add a lot of instrument information together and then calculate that percentage. So ones that is popular is pixels covered by clouds. So defining a cloud pixel, for example, simply will go with white versus non-white, or things along those levels. It can get more detailed, but some instrumentation can do that, yes. Or they add different instrumentation information together to calculate it. Great question. So that leads us back around to data entry. So I'll show an example at the end about how to participate. What we envision is full circle participation. So that comes all the way around back to data entry, is kind of the midway step. So you can do it through data entry on the website. You take your hard copy information and enter it into an online data form on the Globe website. There's the Globe Data Entry mobile app, which is basically a virtual mobile phone version of that exact entry form on the website. And then just this past year, we introduced Globe Observer, which is kind of its goal is to populate easy to use protocols and make them easy and accessible to anyone, anywhere. So I'll show some examples. Actually, I'm not sure if I have any screenshots, but what I wanted to mention here was tied to Joe. Oh, the great thing about Globe Observer is you don't need an internet connection while you're observing. It'll store your data in the app, and when you get back to a Wi-Fi or internet connection, you can then send your data to Globe. So that's what's really awesome about the new Observer app. So Cloud Online Data Entry. This would be the data entry online form. So this is our new, and I know you can't see it that well, but the updated hard copy, which you could print from the site, take out on your clipboard, and then translate that online. And then that feeds this cloud data visualization. So if you're familiar with it, this is what you could access on the Globe site. If not, once you come to the home page, there's a button on the top right that says Data Visualization, and it'll take you right to it. And this, I just have open the cloud observations. It'll pop up your metadata. It'll graph for you. This is where you can access your photos. And then coming in just a few short weeks, you'll be able to access the link that has your satellite match right in it. And so what I mean by it, this is the huge new value that you're getting out of your cloud observations, is by observing during cloud satellite overpasses. So what I mean by that is anytime a Ceres instrument passes over, CloudSat or CALIPSO, or actually if you're in an area that's centered under GEO, which most of the United States is, you'll be perfectly fine. It's an hourly report. You will get that data back to you in an email if you're a Globe teacher, or like I said, you can go to the data viz and click the link. So here we have the Globe Observer from the ground information in a green table. And then as each satellite matches to you, so over time, you could get more and more satellite matches because the instruments send their data back in different frequencies. So for example, GEO, you will get the next day. Ceres can take up to a week. And things like CloudSat and CALIPSO that are imagery, they have a thinner path over the Earth, so their matches are a few more days in between, up to 16 at times. But what happens is those tables will start to store next to each other. You'll get the product as a thumbnail below the satellite information. And then below that, we want the students and the participants to interpret what they see. Fill in the comments. What happens is you submit this, that comes back to the NASA team. It also gets stored in a database where you can always access and pull this table, pull this table back up with your comments included. And what does that look like through data viz? So for example, if I open one of my data points, clicked on it, you could also have a satellite image that you can pop up. It's MODIS within Worldview is the software we use, which is basically like Google Maps for the satellite imagery. And it's centered directly on your location. So you can start to have the students visualize how their ground observation and their data input, which is represented by those circles, translates to the actual image of what's happening above them. Starts out locally, centered over them, to regionally, to globally, they can zoom out. So this is where we're returning to what satellites we match to. So we'll be matching to more over time. Our goal is to stay on top of NASA and cloud-related observations and satellite and instrumentation and feed that into this system. So currently, we match to the Ceres instrument, which studies cloud fluxes, energy in and out of our system. So reflected cloud energy and energy back off of the Earth, and clouds affect that by blocking it or releasing it. And that's on Terra, Aqua, and MPP. So that's the information that's returned within about a week. We also have CALIPSO and CloudSat adding more specific cloud data. CALIPSO is really cool because it adds a curtain. So you see kind of a swath or a curtain of the atmosphere, so vertical imagery. You also get aerosols included in that. And then we match to GOES right now, and as GOES R comes in with the latest and greatest in weather information, we'll be feeding that into our system as well. So I have a few more slides here. And so how to participate. So what I was mentioning earlier is full circle participation to us means that you are observing during a satellite overpass time, which is all the time for us. You're collecting cloud data and reporting cloud data. You're looking at that great visualization, and you're actually taking the time to have your students interpret it. And on the left here, I just added some of the things that Kevin and Joe have already gone over that most of you are already GLOBE educators. One thing I want to point out about that is that opens a world up to you, meaning if you're trained in one GLOBE protocol, you have access to data entry for all of them, which is awesome. Protocol observation and data entry, what we went over with clouds, for example, just above. Kevin and Joe have given an example of student research campaigns that they're part of, virtual science symposiums to submit your students' research to, and basically just explore and do GLOBE. There's so much out there, and we're here to help. So where to connect specifically for clouds? Our team of 2 out of Langley is working with the GLOBE team to get this rolled out to you as soon as possible. We just hit our 150,000th observation for the program for school, so we figure that's a good time to switch over. Content and webinars will be coming out. I know the Mission Earth group will be good about sharing to you guys. You can also, through the GLOBE community, updates and news briefs, see where we'll have updates and webinars kind of walking you through that update. And if you have any questions, of course, you can always contact us at this link, school.lark.nasa.gov GLOBE contact, but I made it and actually I can write it in the chat here when I'm done. I made it a bit.ly link just to be a little bit shorter, but it didn't really help. The last question is new data collection forms. Not right now. Correct. So we're kind of trying to pair it with, as soon as we turn on the new data entry and things on the website, you'll be supported by the content. So we don't want to release one before the other, just so that you're not confused on if you've missed something. So no one has missed anything yet. So how can we get copies of the new cloud charts? We finalized those today. We have versions of the school ones, which is what the GLOBE ones are being updated to. So we have those to provide. The new ones should also be printing soon. As soon as we have the file, we can print them. Also, you can request them from GLOBE just like you would workshop content. Yes, resembles NASA school project. Yep, our goal is to bring the best of both worlds. So GLOBE had a nice, robust kind of support content and process, and was really hitting that middle school and high school. And through school, we had the satellite comparison, and we have that whole elementary community. So we feel like by combining them, we're really getting a good product out of it at the end. Do we need infrared thermometer? You do not. To do the clouds, what you're looking up with is just all you in the report formula cloud chart. What I would say is that would be a really cool addition, because those of you who are also GLOBE educators can then enter surface temperature, barometric pressure, and relative humidity through the related GLOBE protocols. And it would be cool to compare surface temperature with the infrared thermometer protocol, definitely. So you don't need it, but it's a cool comparison. How is NASA actually using the cloud info? Great question, Debbie. So one thing is we store it all in a database that's accessible to the public, but that's also building a validation database. So what's great is when satellites come online, so for example, GOES, if you're familiar with the GLOBE program, they also run a SMAP, was a great example recently. When new satellites and instruments come online, they need that ground validation. So we're a great source for that. We also need you because you are a plethora of data points that we can't get based on personnel, money, and time otherwise. So we don't have all of that. So the students are a needed ground point for us. You're creating a long-term data set. One person can create a long-term data set, but it's really hard. As students over time around the globe we can piece together, for example, with Globe in School, over a 20-year running data set, which allows us to see patterns and series a lot better. And the last thing is you're another layer of understanding, meaning at NASA, our view is from space. We even have in situ with balloons and airplanes, but from the ground, we're only at our centers. So you are that other layer of understanding. I hope that helped. What other resources are available with the new protocol? So coming out at the end of the month, right off the bat, we'll have the updated protocol, specifically within clouds, the field guides, the cloud report form, the cloud ID chart, and e-training slides and citizen science tutorials. Once we get those out and up and running, we'll filter back and go through the protocols that touch clouds and make sure they're up to date as well. And learning activities, they're all still applicable, and we're adding one about opacity and hope to add one about data. Lynn is also reminding there's also paper on the results of school coming in March through BAMS. Yep, and I'll be sure to put that up on the website when we have a link. And will we need to complete the new e-training slides in order to collect and submit data? No. If you are a protocol trained educator, Globe educator, you are in there. If you're all Globe, for example, say you just happen to be part of the school community, we're bringing you over and you'll have a Globe ID. So you're all set. How close in time and distance from the satellite overpass should we make the observation? Good question. So all of this will be on the website in supplemental information. But what happens is if you're matching to series, we ask that you observe within 15 minutes of the overpass time, and we calculate the overpass time based on your location. So we make sure you're within the right distance. So within 15 minutes of either side of the overpass. And now with GEO, you can basically observe any time during the hour and get a match. What I would suggest with GEO is GEO has basically a circle focused on one part of the Earth, and it scans like this. And so depending on where you are, you'll usually hit the same time of that hour each hour. So if you observe closest to the return on that data, you'll basically get a more comparable match. Has any content been developed with adaptations, modifications for special education students? We do try and make all of our content 508 compliant, but if you have an update, we're happy to work with you, and we'd love to also provide it with the on the website. And also, you can't see me. So I'm gonna stop sharing my screen. Okay, can you see me now?
Yeah, we can see you.
Okay.
All right, I wanted to ask you something, and there's actually, I think, a number of students on the line right now.
Oh, great.
What is your job at NASA, and how did you get there?
That's a good question. So my path was kind of all over the place because my goal was to say yes to every opportunity that came my way. So my current job is an education and outreach coordinator for the school program. So I help people register for the program, provide them resources, answer any of their questions, and then also kind of assess some of the data when it comes through and make sure we have scientists helping with that. But I got here I went to Ohio State for atmospheric science, and I thought I wanted to be a weather girl, and that didn't turn out to be for me. So I went to Smithsonian to do some research, and that didn't turn out to be right for me. So I ended at NASA, and I felt like the missing piece was people. So at each one of those, it was just me and a camera or me and a plant studying CO2. And I felt like science was really the personal connection and having to explain science back and forth and come to an understanding together. So that's where I am now, and we'll see where the next step takes me. I'm looking forward to the Globe integration because that's a new program that I'm learning as I go. So there's always a next step.
Globe is a nice family. That's the thing about Globe. It's great.
Exactly.
You get to know people. I've known some of the people who are on the line here for 15 years or better. That's pretty cool.
Yeah.
So one person put in the chat box, can you explain better how to measure with hands?
Oh, yes. So measuring with your hands is a good tip and trick if you're, for example, looking at a cumulus cloud. So what this ties to is how do we kind of better tell the different layers of the clouds we're trying to look at. So good tips and tricks to start off with is just if you see layers, is one cloud behind another cloud, and then we can start to assess if they're low, mid, or high. With cumulus, for example, with your hand, you can hold your arm out at your fist out at arm's length, and if the cumulus puff is closest to the size of your fist, it's usually a low cloud. And as things get further away from you, they get smaller. So if the puff is close to your thumb or thumbnail, it's mid-level, and if it's closest to your pinky nail, it's high level. So as that puff gets further away from you, it gets smaller. There's also something I was going to say about levels, but oh, with hands too, you can define your observation area. So basically the main goal is you want to be looking at your sky without any distraction of horizon or distortion of the clouds. So a tip and trick we do is, a really good example is from Joe's slide earlier, is to hold your hands up in a V shape, kind of with your hands just above eye level or at the top of your head, and observe between that area between your hands. You don't want to observe kind of across the sky because especially with cumulus clouds, that shape and cloud cover might get a little distorted. So the goal is up without distraction of horizon and without distortion of clouds kind of across the horizon. I hope that helped.
That's good for me.
Great.
All right. Any other questions for Sarah or Joe? So I will say any teachers, I'll offer Sarah as a science resource because you do have a science background, right?
Yes. Yeah. Please let us know how we can help.
Yes. And if anybody wants, students, you can email me questions about your projects. I can send them to Sarah. You can email Sarah. You had her email address there. I would encourage you to do that because actually I haven't gotten any questions this year at all from any students. So this is a kind of a slow year so far. All right, well, I'll wrap it up here. And people are saying, nice job, Sarah. So I agree with that. It was great. Really appreciate
Of course. Thanks for the opportunity, and that we're just trying to get to everyone. So if you have some follow-up questions, we're happy to help in your classroom or answer a quick email. Just let us know how we can help support you. And Mission Earth is kind of a great channel because they do such a great job with the teachers in the classroom. So thank you, Kevin, and let us know how we can help.
Well, you're welcome. I do want to give a heads up. Our next webinar will be in 2 weeks on February 22nd. 8 p.m. Eastern Standard Time. So we've been doing them every 2 weeks. Our teacher feature will be Marcy Burns from Main Street School. And I kind of put me as a NASA nugget. I'm not sure if I count as NASA anymore. I used to have a NASA badge. But I'm going to be showing the globe visualization. So any students or teachers, if you're helping your students to gather data from the globe website, we're going to go over the globe visualization, how to get data out of the globe website so you can do comparisons. And thank you all for watching, logging in. We do have a Facebook page, so you can go there and see posts about the webinars and anything about globe. And then there's also a YouTube page we have. Apparently you have to go to YouTube and then do a search for Globe Mission Earth. And you can see past webinars that we've done. All right. So I wanted to thank you all. Have a good night. And if you're on the East Coast, I guess buy a snow shovel. I don't know.
Yeah.
All right. Good night, everybody. Repost emails. So Sarah, can you post your email in the box?